Now let's start with two very important feature of NumPy array. As you can see here, the first one we will discuss on filtering, and second one we will discuss on reshaping. So anyway, reshaping I'm coming later. What is filtering? You all know filtering means that you want to basically again you want to extract some set of elements or some elements from the array based on some maybe some criteria. That criteria will filter some data from the array and will discard some another other data of the array, right? To understand how this filtering works, what I have done, I have basically created a random array having this particular dimension. So if you just run this particular cell, you will get what you are getting. You see, you are getting a array of dimension 2 cross 10, that means 2 row and 10 column, okay, where the elements of each and every cell will vary in between 1 to 30, and that is why we require this particular function of numpy package, okay, which basically creates a random integer, okay. And as you can see here that some values has been repeated because there is no such you know criteria that repetition will not be there. So random, this dot randint can generate more than one occurrence of the same data. Anyway, now suppose I want to extract all the data that which are basically greater than 10 in this particular array. So what to do? I can simply write this particular criteria, and based on that, if you run this particular code, what you can see here, you are not getting any data. Rather, you are getting a Boolean expression, either true or false. So basically, this is the first row that you can see. You have understood, I think, because the rows are a list. All the rows are basically list, and the whole matrix is list of lists, because this is one list and this is another list, which are separated by a comma, and all these two lists are stored within another list that already you have seen in previous example over here. Say something like this one. This is one list, this is another list, which are separated by comma and which are present in another list. So it basically list of lists. So in that case, in case of more than one dimensional data, the array represents all the data in form list of list, something like that, right? Anyway, so let's come to this point, that what basically this criteria criteria or results, the criteria results form of a array of each and every element as boolean, and this boolean true or false will be generated based on the value which is greater than 10 or not. Since 20 is greater than 10, that's why this is true. Since 10 is greater than equal to, sorry, it's greater than equal to, actually if 10 is greater than equal to 10, obviously equal to 10, so that's why it's true. For 16 it is true, for 25 it is true, but for 8, obviously it is not greater than equal to 10, so for 8 you see you are getting a data false. And naturally, as I told you, that it is creating a random integer. If I just run once more this particular line, you see definitely the numbers has varied, right? And based on that, if you run this code, for example, now I want array greater than 10, this particular criteria, not greater than equal to. So what will happen if I run this code? The true and false will change in some sense, right? True and false will change. Now you see that for example, sometimes you may ultimately, I mean, as I told you, that suppose this is the data set presently you have in your hand, Okay, and you want to work with those data which is greater than 10, and you want to discard the other data. But if you just apply array greater than 10 this particular criteria, it is basically returning another array having only true and false value, some boolean values. But you cannot work with boolean value right now because ultimately you require data. For example, if I compare manually, I will get 23, 19, 19, 30. I mean, lot of repetition is here. Okay, let's, I mean, do it once more. Okay, so there is now few repetitions is here. So 18, 17, 10, 10 definitely will not come because 10 is not greater than 10. So 18, 17, 13, 21, 25, 23, all these values should come to, I mean, should be filtered out, and I'm sorry, filtered in, and 7, then 10, then if possible some other values. Right now there is no other value present, only these two are false, so these will remain filtered out. So let's do one thing, let's keep it 1 to 20. Maybe in that case it will be easier to, discard. Yes, so there are many values which is less than 10. So I can now, if I run this particular, this particular statement, I'll get lot of false values and true values as well. Okay. Now, since I want to work with data. That's why, based on whatever value which is true, I need only those values, right? That's why you have to apply one more a technique, something like this. What it is doing? You see, I'm basically writing array of those indexes I want whose index will be true over here. Okay. For example, if I just want to create a simple array, not two-dimensional array. Say let's take only one-dimensional array. Okay. Is it possible? Yes, it is possible, right? It's a one-dimensional array, so let's make it little simpler to understand. And here I have some values which is greater than 10, some values which is less than equal to 10. So if I filtered it, I will get some true and false values, right? For example, false, true, 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 false, false, something like that. What I require, I want to filter the value greater than 10. That means 11, 15, 16, 15, 12, 16, all these values, right? But if I only apply ARR greater than 10 criteria, I'm getting an array with true and false. To get only those values which are true, what we can do, we can extract it in something like this. We can write ARR within third bracket the criteria I can store. Okay, I mean here the criteria is greater than. So if I keep the same criteria and if I run this particular code, you see what will happen? It's actually extracting only those values which is greater than 10. You see, in this case it is coming true and false, and in this case it is coming value. Why? Because what actually it is doing, it is, you can say, it is basically doing ARR of this particular criteria, this particular, you can say, uh, list. So for example, instead of writing, just to show you here, instead of writing this one, I'm just inactivating this line and storing here as ARR equal to ARR of this. Okay, ARR of this. You see what will happen? Let's see. If I run this code, oh sorry, I have to print this. And if I run this code, sorry, oh I'm sorry, it has to be, okay, okay, it's actually creating all the false here. Okay, so I have to, I think, do something like this. Yes, now I think it will work. No, I'm sorry. There is a mistake from my side. I'm sorry. So I think I cannot explain in this way. Anyway, the thing is that what I mean to say is that what actually happening here, that ARR greater than 10, this particular criteria is representing this particular um, boolean array, and this boolean array is input to this particular particular third bracket of this one, and based on whichever part is true, the position of that particular value is coming over here and it is being printed as you can see here. For example, you can see something like this. I'm sorry. uh, oh, I'm sorry, it's already, have to enter it once more and then I have to print. Yes, now it is coming. What happened? Oh, ARR equal. Wait, let me check it once again. If I put this code here, mm, should it work? Let's see. Yes, you see this is working. Actually, maybe I had some mistake for writing code, but what is happening, you see here, I'm just passing the, instead of passing some criteria here, I have just passed the boolean array, and based on the part which is true, and in the same position, whatever value the array that it has, this 8, 16, that has came in this scenario. Okay, so this is a way by which we can filter some data from an array, and this is, I hope you can easily understand that only those value which is equal to 25 will come. So I don't have any value which is 25 here right now, right? So if I just print, if I just run this one, you will see you are getting a empty array because there is nothing in the array. So that's why it is representing an empty array, and whose data type of each and every element is 32-bit integer value. As simple as that. So this is about filtering part. Now let's come to the reshaping part. What is reshaping? Reshaping, from the word, I hope you can understand that basically the shape of an array we can change according to our requirement. Okay. For example, there is it's a very beautiful feature that we have in Python language, which is not present in C that we have seen. For example, you have a one dimension array, 20 locations, or 20 elements of 1D array. If you have in C language, you can work with that, but you cannot change dynamically the shape of that array from 1D to 2D. You cannot do that, right? But this feature is present in Python. So what you can do, you have to call a function reshape. For example, over here, as you can see, like ARR, this particular line is just used to create an array. You understand that because np.arrange already you have seen. Now, what this np.arrange 20 is doing, it is simply creating a 1D array of 20 elements. Now remember, 20 elements, if I want to put in a proper 2D fashion, I can put in different way. It can be 4 rows, 5 columns, or maybe 2 rows, 10 columns, or maybe 5 rows, 4 columns, anything. So based on my requirement, I can change the shape of that array ARR using this reshape function, and within the reshape function you have to pass the the but you can say the number of row and number of column. But remember one thing, that when you are applying, you can apply this reshape function on an array, but it does not change the schema of the original array. That's why after reshaping, you have to store those data in the reshaped format into a different array. Okay. If you want to do that, definitely You can change over here as well. You can write ARR as well, but you have to specify something like this. Then only it is changed. If you write only ARR dot reshape, it is not going to change the schema of ARR directly. Anyway, so over here, if I just run this code, what you will see, basically you will see a data having 4 rows and 5 columns. Now instead of 4 rows and 5 columns, by mistake, if you have 4 rows and 6 columns, let's see what will happen. You see you are getting an error. Why? Because you cannot distribute 20 elements into 4 row and 6 column 2D array, because 4 row and 6 column 2D array means 24 locations, right? And you have 20 data. If you have a mismatch, then Python will get confused and it will throw an error. As simple as that. Okay. Now, so remember one thing, that this particular dimension has to be matched. The total number of elements has to be matched. Okay. So if you want to keep, for example, 2 over here, then you have to put here 10. Because 10 into 2 means 20. 10 rows, 2 columns. So if I run this code, you will get, you see 10 rows and 22 columns. So you have 10 rows. Even you can have 2 rows, 10 columns. So any variation possible according to your requirement. But remember, it has to be same. This is one thing. Now, after this, if you print the dimension over here, you can see here it is representing 1, 2. Why? Why 1, 2? What is ending? Remember, ARR of ending is 1, right? Because I have only a single, as like a 1D array. That's why the dimension is 1. But after reshaping and stored in a new array, like new underscore ARR, here the dimension is 2 row and 10 column. That means dimension is 2, row and column. That's why you see it has come as 2. So in this way you can change your. Now it is not like that you have only a one dimensional array and you can change it to 2 dimension. No, even you can do the opposite one also. Like you can discard another dimension of a 2-dimensional array and stored in a 1 dimension, just in opposite format. For example, over here, you see, if I let me run this and then explain. You see here that presently, yes. So what it is doing, it is basically first creating a vector of 1 dimension, right? Right. Similarly, now by this particular line, what basically we are doing, we are reshaping this array. We are reshaping this array to 2 dimension, but I'm making the numpy last dimension by itself. For example, the last dimension can be defined by itself. For example, you see, I have given 2 rows, okay, but I have not specified how many columns is there. I have written -1. It means that I have said Python that I want to keep 2 rows and to keep the same, to to store the 12 elements in 2 row. You decide how many dimension you require in the column part. I have not decided here. For example, instead of -1, I can write 6 as well. If I write it, it will run and it will be the same. But by mistake, if I write 5, I will get an error because it is not matching. So I have to understand what should be the value of row and what should be the value of column, and multiplication of them should be equal to 12. So if I write 2 here, I have to divide 12 by 2 and write 6 here. But what I want, I'm just sharing a different approach here. Okay, remember, it is not like this is the only approach. Suppose you have some n number of values, okay, and this n number of value can be divisible by 2 or can be divisible by 3. Sorry, for example, it can be divisible by 3. For example, you have a say, for example, array of say few lakhs of elements, okay, few lakhs of elements, and you want to know surely that the number of elements present in your array can be represented in form of say 10,000 row and some thousand of columns, something like that. So if you want to represent those lakhs of elements into that some 10,000 rows and some thousands or hundreds of columns, in that case what you have to do, you have to first divide those lakhs of columns by 10,000 or something like that, and the remainder, sorry, the quotient you have to put here. For example, I have 12 elements and I want to represent into 2 rows, so I have divided 12 by 2. The quotient that I have kept here. But assume that this particular value is not 12, it is very large, and you are sure that you can represent that very large amount of array. You can arrange that very large amount of array into, say, for example, 35 rows, but you don't know what number of column will be. In that case, what you have to do, you have to divide that very large number of value by 35, as I have done here, 12 by 2. Then the quotient that I have will be written here. So I need some computation, but I don't want to waste time. What I can do, I will simply write -1 here. If I put -1 here, then Python will do the division on behalf of you and will decide how many dimension in this column side you need to keep the shape as it is. I mean, as it is means to keep the shape correct. For example, I have here 2 minus 1. It means it is representing two row and 1, 2, 3, 4, 5, 6 columns. If I represent instead of 2, I represent 3, sorry, 4. Then you see Python will decide for arranging these 12 elements into 4 rows how many column I require, and Python will understand it requires 3 row, and Python will do it by you. Instead of calculating by you manually, Python will do the calculation on behalf of you. So this is a very interesting feature that we have for the programmers. Now, as I told you, that you can change your dimension from higher to lower as well. For example, over here, as you see that here you have a 2-dimensional array. I hope you can easily understand, right? If you print only error, I'm just writing here, it will basically print a 2D array, right? Okay. Now what I am doing here, you see I'm writing here error dot reshape -1. It means that it will discard the column dimension and it will basically flatten the whole array of 2D array. So flatten means all the row will be concatenated with each other. So 1, 2, 3, and After 1, 2, 3, 4, 5, 6 will be concatenated. Then 7, 8, 9 will be concatenated. And as a whole, what you will see? You will see only one dimension. So if you just print this statement, this updated code here, you see you are getting 1, 2, 3, 4, 5, 6, 7, 8, 9. So what it is doing? It is basically concatenating all the elements of the array row wise. That's why it is written flatten the array. Okay, so these are the very important features that we have in NumPy array. And there is some cheat sheet over here for you. You can use some various mathematical operators and for filterings and all that already we have discussed here. So these are the few points in NumPy array that you have to remember when you will start writing program and use NumPy array in your